Hey students, today we are going to talk about the rate of energy transfer in the section of heat and gases. The learning objective for this chapter is to define power as the rate of energy transfer. We have talked about the ways of heat transfer such as convection, conduction, and radiation in the previous chapter. And now let's talk about how fast is energy transferred from one to another, which is the power. I would like to introduce some units for energy to you first. We know that the unit for energy is joule, but actually we can use some of the smaller or bigger units for energy. The first one would be millijoule, which is 1 times 10 to the power of -3 joule, which means that it's a smaller energy unit compared with just joule, which 1 millijoule represents 0.001 joule. And the second one would be kilojoule, 1 kJ, which is 1 times 10 to the power of 3 joule, which is 1000 joule. And then the last one would be 1 megajoule, which is even greater units of energy, which is 1 times 10 to the power of 6 joule, which is how many 0? 1, 0, 0, 0, 0, 0, 0 joule. So that if you need to write a very large value of energy, which is the 100,000 joule, then you don't have to write a lot of zero. You just write down 1 megajoule, then it's fine. And when you see these values, these units, I need to make sure that you know how to convert the units back to joule, or need to make sure that you understand what's happening. And then finally, we can talk about power. Power, as I said just now, is the rate of energy transfer. So higher power, faster speed of energy transfer, and lower power, then smaller rates. The rate of energy transfer would be slower. And the equation for power is P. P is power equals to E over T. And P, let's write down, P is the power. And what is E? I think you know that it's the rate of energy transfer, so E is energy. And what is T? This is a small letter of T. Don't mix up with the capital letter of T. This small t is about time, but not temperature. And from my experience, some of you will always think that this T is temperature, but eventually it's just time, because we're talking about the rate. So it's how much energy can be transferred within a period of time. There is power, and if there is a higher power, then more energy E could be transferred in a given time, which means that within the same period of time, if that device can provide you more energy, then it has a higher power. And we write down this as number 1. Another approach of looking at power would be, if there is a higher power, then if you want to transfer a fixed amount of energy, if the power is higher, then of course it requires a shorter time. So you can relate power to energy and also time. And this may be a little bit abstract, so let's take a look at the examples below. So kettle A and kettle B, which one has a higher power? So let's see, kettle A has the ability to boil 1 kg of water, in 5 minutes. And kettle B can boil 1 kg of water. You see that the mass is the same and they are both water, so it's a kind of fair test. And this kettle B can boil 1 kg of water in 10 minutes. So let's just look at the numbers. They can boil the same mass of water with different time, and kettle B requires longer time. So which one do you think that it has a greater, higher power? And as kettle A can boil this amount of water in a shorter period of time, in a shorter time, T, so that means that kettle A has a higher power. And why? Because it can use a shorter time to transfer the same amount of energy. Sorry, this one should be reason 2. So which reason? It's about the time, right? It's the fixed amount of energy but different time. So for simplicity, we just write down reason 2. And another example would be the oven here. You see the time. Both of them spend 30 minutes. But oven A can bake 2 kg cake, but oven B can only bake 0.5 kg cake. So that means within the same period of time, which is 30 minutes, oven A can bake larger mass of cake, which means that it can transfer more energy within the same period of time. So this time is also A. Oven A has a higher power because it can transfer more energy within the same period of time compared with B. So what's the explanation? This time is about more energy within the same period of time in a given time. Okay? So after you understand or you learn the concept of power, energy, and time, then I would like to also explain the units of power, which is watt. W, watt. So 1 watt equals to 1 joule per second. Why? Because relating back to the equation, power equals to E, energy, over T, time. And what's the units for energy? Is joule. What's the units for time? Is second. So power is energy over time, which the unit is joule over second. So is 1 watt equals to 1 joule per second. And you can try to convert the units. I think if you understand what is kilo and milli, then you should be able to deal with these conversion of units. And this is important. This is important because in the questions, in the problems, they always use different units to trick you, and I'm confident that you can deal with it. So for you to easily understand it, we are going to talk about the constant power, which means that the power of the device or the machine providing to heat something which is constant. The power is not changing. So let's say in this example, the power is 800 watts, which means that in 1 second, how much energy can be transferred from it? Yes, it's 800 joule. So for 1 second, the energy transfer would be 800 because the definition of power is the energy over time. So 800 watt means that 800 joule is transferred in 1 second. And how about 2 seconds? Simple, just times 2. So it's 1,600. 3 seconds times 3, 2400. And then 4 seconds, 3200 is 3,200. So how about 6 seconds? You know it's just 800 times 6. Power times the time. So how to get the formula for energy? You just change the subject, and when you see that power equals to energy over time, then you want the E, right? You just move the T here, simple mathematics, so that eventually you will obtain this E, energy, equals to PT, power times the time. And if the power remains unchanged over time, which means that the power is constant, then the time t here, and the energy E, they will go up in the same proportion. In a more mathematical word, which is E is directly proportional to T. When T increase, then E increase. So the total energy transfer is power, which is constant for this time, power times time. And remember, this P does not depend on T, because now we are talking about a constant power. We talk about the constant power. We know that the power is constant this time, so that it does not depend on T because it doesn't change. But the energy here depends on the time. A longer time, there should be more energy transferred. And let's have a look at this example one. Two electric kettles A and B have consumed different amounts of energy within the same period of time. So you can see that if within the same period of time they consumed, which means that the different amounts of energy is transferred, then A and B probably have different power. And they are filled with the same mass of water, otherwise it's not fair to compare with the energy transferred. It's not fair to compare with the power. And this time, what is the power of A and B? So you can simply apply the formula we just talked about, which is P equals to E over T. And then for A, which is the power of, for simplicity, we just write down A, which is energy over time. So it's 6.0 times 10 to the power of 5 over the energy over the time. Is it 5? Yes, no, it's not 5 because it's 5 minutes here. Remember, we defined the units for this time here should be seconds. So it's 1 minute, there are 60 seconds, so it's 5 times 60. And by calculation, the value should be 2000 watts. And for the power of B, is could be obtained in the same way, so I'm not going to talk about this. You can calculate it by yourself. And which power should be higher? Which one, A or B, should have a higher power? And you can just look at the energy here. Which one consume more energy within the same period of time? A, right? So which one has a higher power, and which kettle of water will boil first? You can do it by yourself. So let's move to page 3. Page 3, the example 2 is a more complicated example because this time is not just directly substitute P equals to E over T. This time, a solar water heating system has a solar panel of area 0.5 meter second. And you know that it's so hard for it to capture all the energy received. I mean, it's so hard to capture all the energy given by the sun, right? So it just captures 25%, which is 1/4 of the solar energy it receives, and use the energy to heat water. And this is a very important information here. There is assume sunlight delivers energy onto the Earth's surface at 1 kilowatt per meter square, which means that for 1 meter square like this, if this is 1 meter and this is 1 meter, then for this surface, the power would be 1 kilowatt. So you can see that this time the panel does not have an area of 1 meter square. Instead, it has an area of 0.5 meter square. So in the calculations, you need to also consider the area here. And I will upload the answer to you later, but this time I would like you to try by yourself first. And in case you don't know how to obtain the energy, and you can see that from the previous pages, energy here is power times time. So try to use this formula and use all the informations here. And one last thing is minutes again. So convert the unit for me. And apart from joule, there is also a very common unit for energy. And it looks so strange, kilowatt hour. Why you see kilowatt here? Why not power? Because it's also hour here. It's kilowatt hour. So this kilowatt is a unit for power, and this H is hour. Hour is a unit for time. So try to get this concept into your mind, which means that 1 kilowatt times 1 hour, which is first 1 kilowatt is 1000 watts, done, and then 1 hour is 60 minutes times 60 seconds, so 1 hour is 3600 seconds, and then we just multiply it, which becomes a very large value, huge value, 36000 and 0. Then a lot of 0 here actually is 3.6 megajoule. So it's a huge value, but if you use this kilowatt hour, then you don't need to write down a lot of 0 here, and it may confuse you. And how to measure the energy supply? We can use some appliance. Some of the tools. The first one would be joule meter, and it's easy to remember these devices because it is named with the units of energy, joule and also kilowatt hour. And for this example 3, it is also a very typical example which only requires you to understand the power, the concept of power equals to energy over time. So a total of 45 kilojoule of energy is supplied to an electric fan in 10 minutes. You got every information, energy, and also time. So what is the power? In case you are confused, then first you can write down the formula here to remind yourself first. You got E, you got T, then of course you can get P easily. And for part B here, this time the time is 3 hours, and give your answer in the kilowatt hour. So try to do this. If you don't know how to do it, you may have a look at here. It provides you the information that you need. And then let's turn to the last page, page 4 of your notes 2.1. Energy time graph. Actually, when we study physics, we always look at the graph because a graph can tell you a lot of information that you need. And for this time, we look at the energy time graph. Why energy and time? Because energy and time is related to power. And this graph, energy time graph, shows how energy supplied varies over time, which means that along the time, how is the energy supplied, which can be seen from this energy time graph. And if the power is constant, use the same example, which is 800 watt here. If the power is constant, then the energy supplied over time is constant, which means that if 1 second has passed, then 800 joule is transferred. And if 2 seconds are passed, then 1600 joule of energy is transferred. So it's a straight line because the value for energy over time is constant, is 800. So it's a straight line. It would not go like changing or become a curve because it's always the same. It's always the value energy over time is always 800. So what we call this slope here, the slope is the energy supplied divided by the time. And you can see that it's always the same because the concept here, the power is always the same. So energy over time is power. So it's always the same. For this case here, for this one, it would be always 800. So a constant slope, which means which represents a constant power. If the slope is constant in the energy time graph, constant power, and the slope of this energy time graph is just energy divided by the time, which is power, according to this equation. And then the last example I would like to introduce is example 4. You can see that here there is two straight lines here. The graph shows how the energy consumed, E. Energy consumed is E. How the energy consumed varies over time T of two electric kettles A and B, which means that this straight line is for A and this one is for B. And they provide you all the values, of course, for sure. And they need you to estimate the power. So before we calculate, just intuitively, we look at it with common sense. A or B should have a higher power. For A, it just takes 4 seconds to transfer 5,000 joule of energy. But for B, how much time does it need? For B, it takes 10 seconds to transfer the same amount of energy, which is 5,000 joule. So A can transfer the same amount of energy with shorter time. Then that means A has a higher power. And how to calculate, how to estimate the power? You just use this P equals to E over T. And here there's no values stated in the question, but all the things are in the graph, in the ET graph here. So for A, the power of A here is energy over time. And how much energy did it consume, which is 5,000 joule. You don't need to convert the unit because it's joule already. And this time is very convenient because the time is also second, so you don't need to convert the unit. And how many seconds does it take? It's 4 seconds for A, so it's just 4, which equals to 1,250 watts. And similar for B, you just use the same formula to get the B, and eventually you will know that A has a higher power, right? It's simple. And after we talk about the energy time graph, I want to challenge you with another graph, which is power time graph. And this time, we talk about how the power varies over time. You can see that energy is transferred to water for this case because you use a heater to heat a beaker of water. However, this time, is the power changing? Is it changing? And how to find the energy transferred? So here you know that P equals to E over T. And then changing the subject, you can know that E equals to power times the time. E equals to PT. So how to get this PT here? P times T is the energy. So which means that is the area under this graph. The area would be the energy transferred because it's PT, is P and T. So let's try this example and have a quick check with the answers uploaded by me. So that's all for today.